8333. When stopping a nose-wheel-type airplane after taxiing, the nose wheel should be left. A. Unlocked and pointed straight ahead. B. Turned at a small angle towards uphill if the parking area is not perfectly flat. C. Pointed straight ahead. The correct answer is C. When stopping a nose-wheel-type airplane after taxiing, the nose wheel should be left pointed straight ahead. This helps to ensure that the airplane remains stable and does not roll or drift on its own. If the parking area is not perfectly flat, the pilot should use chocks or blocks to secure the airplane's wheels and prevent it from moving. 8334. When first starting to move an aircraft while taxiing, it is important to A. Test the brakes. B. Closely monitor the instruments. C. Notify the control tower. The correct answer is A. It is essential to ensure that the aircraft's brakes are functioning correctly before starting to move the aircraft during taxiing. This will help avoid any potential accidents or safety hazards on the runway or taxiway. Once the brakes have been checked, it is also important to closely monitor the instruments to ensure that the aircraft is moving at a safe and appropriate speed. 8335. The color of 100 LL fuel is A. Blue. B. Colorless or straw. C. Red. The correct answer is A. Typically, turbine fuel is colorless or straw-colored. Red dye is added to aviation grade B0 fuel. A. Blue-dyed low-lead, 1-octane aviation fuel. 8336. How are aviation fuels, which possess greater Antiknock qualities than 100 octane, classified? A. According to the milliliters of lead. B. By reference to normal heptane. C. By performance numbers. The correct answer is C. Aviation fuels that have greater Antiknock qualities than 100 octane are classified by performance numbers, such as 100 divided by 130 or 115 divided by 145. These numbers represent the lean mixture rating, MON, and rich mixture rating, RON, of the fuel. The higher the numbers, the better the Antiknock properties of the fuel, which means that it can resist knocking or detonation in aircraft engines with high compression ratios. 8337. Why is ethylene dibromide added to aviation gasoline? A. To remove zinc silicate deposits from the spark plugs. B. To scavenge lead oxide from the cylinder combustion chambers. C. To increase the Antiknock rating of the fuel. The correct answer is B. Tetraethyl lead is added to aviation petrol to improve its anti-detonation properties, to increase its critical pressure and temperature, but deposits left inside the cylinders from the tetraethyl lead foul spark plugs and cause corrosion. So ethylene dibromide is mixed with the petrol in order to get rid of the residue from the tetraethyl lead. Lead and ethylene dibromide mix during the combustion of the petrol to produce volatile lead bromides that escape the exhaust pipe rather than forming solid pollutants inside the cylinder.